Good morning, students. In the today's session, we'll learn about Bluetooth. Now, the Bluetooth technology is the implementation of a protocol which is defined by the IEEE 802.15 standard. And this standard will define the wireless personal area or network operable in an area the size of a room or a hall. Now we are seeing the Bluetooth devices as the gadgets. And now see here, the devices will find each other and make the network called a piconet. Now, in the next continuous, we'll learn about what are the applications of the Bluetooth. Here, what are the applications of the Bluetooth? Now, whenever we are learning about the applications of the Bluetooth is a wireless LAN network. Okay, here this is a wireless LAN technology which is designed to connect the devices of with different functions. Like we can also connect the Bluetooth with our telephone, notepad, desktop computer, laptop, camera, printer, office markers, everywhere we can use. Okay, and the peripheral devices like wireless mouse and also keyboard can be connected with the Bluetooth technology. And the monitoring devices can communicate with sensor devices in a small healthcare centers also. And whenever if we are seeing the applications, the home security devices can use this technology. Especially we are seeing this Bluetooth technology on the camera webcam. CC cameras also. And for the conference attendees can synchronize their laptop computers at a conference also can be done with the Bluetooth. Okay. And next to see here, like whenever we see like the Bluetooth, it will be where everywhere we can use work with the Bluetooth technology. Now here, now what are the layers for the Bluetooth? Whenever if we are learning with the Bluetooth will divide uses several layers such as radio layer, baseband layer, as well as L2 cap layer, and also the application layer. Okay, here, where is the first layer is what? The radio layer. This radio layer is the first basic layer. It is roughly equivalent to the physical layer of the internet model, and the Bluetooth devices are low power and have range of only 10 m. Okay. And whenever we see the band for the Bluetooth uses the 2.4 gigahertz listen band divided into 79 channels, and each and every channel is of 1 megahertz. And the next here we have this FHSS. What is this FHSS? This is if the Bluetooth uses the frequency hopping spread stream method in the physical layer. Okay. And to avoid the interference from other devices or other network. And here we have bit 1 and 2 are represented by a frequency deviation above and below the carrier respectively. Okay. Now, whenever if we are learning about this Bluetooth layer, we have radio layer, baseband layer, as well as the application layer. And what is this baseband layer? The baseband layer is equivalent to the MAC sublayer of the LANs. Whenever we have working with this local area network, we have MAC sublayer, medium access control sublayer will be there. Okay. And this access method is the time division multiple access. And the primary and secondary will communicate with each other using the time slots. Okay, and the length of each and every time slot is 625 microseconds. And the communication is only between the primary and secondary level only. And the secondary station cannot communicate directly with other. Okay, whenever if we have this baseband layer, it is only equivalent to the TDM MAC layer. And whenever if we have this, the secondary stations cannot communicate directly with the one another. And next here, the frame format for the Bluetooth basic layer is baseband layer is a frame is baseband can be one of 3 types. We may have either 1 slot baseband will be there, and we also have this 3 slot as well as the 5 slot baseband will be there. And the fields in the header are like we have the access code. First field in the header are we have header and will be there, and the first field in the header is the access code. What is mean by this access code? Here in the access code, here we have this 72-bit field normally contains synchronization bits and the identifier of the primary to distinguish the frame of one piconet from another piconet. Okay. And whenever if we have this frame format, it will be Okay. And now here in the header part, we have 72 bits. And next we have 54 bits header. Like in the access code, we have the header part is 54. And in this, the address code, here we have the address of like 3 bits as well as the type is the 4 bits. And each and every field is 1 and the HEC is 8 bits. Okay. And next here, whenever if we are learning about this header, like whenever if we have this header part, like the 54-bit field here, see here we have the 54-bit header. In this 54-bit header part, we have address of address of 3 bits, type is 4 bits. Here the address of 3 bits. That means here the 3-bit address, the 3-bit address subfield can be defined up to 7 secondaries. Okay. And if the address is 0, it is used for broadcast communication from the primary to all the secondaries. And whenever if we have the type as a subfield, for this type subfield, that 4-bit type subfield define the types of data coming from the upper layers. Okay. And in this we have 1-bit subfield will be there. Here we have F as a subfield. This 1-bit subfield is for flow control. When we set as 1, it indicates the device is unable to receive more frames. Okay. And here, whenever if we have A, that means this 1-bit subfield is for acknowledgement. This F for flow control and 1 for the A for this acknowledgement. This Bluetooth, it is going to use a stop and wait ARQ. And 1 bit is sufficient for the acknowledgement. See, whenever if we have this header part, in the header part, we have this address part will be there, as well as type and FA. All these things can be covered in this. Okay. And we have the other is sequence number. Here previously we have the flow control, then we have acknowledgement, then we have the sequence number. And this 1-bit subfield hold a sequence number. Okay. And the Bluetooth, it is going to use a stop and wait ARQ. 1 bit is sufficient for sequence number. Next, we have the header error correction subfield. It is a checksum to detect each and every 80-bit header section. Now, finally, we have this. Wait. Yeah, H is. Okay. And finally, we have the payload or data. The subfield can be of 0 to 2740 bits long and it contains data or control information which is coming from the upper layer. Okay, which is coming from the upper layer. Next. Here, the next layer, what we have here, baseband layer will be there. And next medium, next we have the L2 CAP, logical link control and adaptation protocol. In this logical link control and adaptation protocol, here it is equivalent to the LLC sublayer as well as the LADs. Okay. And it is mainly used for data exchange on the ACL link. Okay. And next here, in this, whenever we have this L2 CAP layer means, here also we have the 2 bytes of length and 2 bytes of channel, and the data control is of from 0 to 65,535 bits. Okay. And in this here, this is the third level of layer which we have. And in the next layer of layer, what we have here also, we have the length of 16-bit length, which defines the size of the data in bytes, and that is coming from the upper layers. Now the channel ID defines a unique identifier for the virtual channel, which is created at this level. And whenever we are learning this about this L2 CAP, here we should learn about what are the, we should also learn the duties of the L2 CAP. What are the duties of the L2 CAP? One is a multiplexing and another one is a segmentation. Next, reassembly and quality of service, as well as the group management. Generally, what is mean by multiplexing? Whenever if we have the communication from multiple channels, will be combined into a single and it will be sent. Okay. And at the same time, whenever we have this multiplexing, at the sender side, the L2 CAP accepts the data from one of the upper layers, frames, then delivers them to the baseband layer. And at the receiver side also, this L2 CAP, this frame is going to accept a frame from the baseband layer, and it is going to extract the data and delivers the data to the appropriate protocol layer. Now see here, now we just learning about the duties of the L2 CAP. Now here we'll see what is segmentation and reason. What is mean by segmentation? The maximum size of the payload field in the baseband is 2774 layers or 343 layers, and it is going to include each and every way the 4 bytes to define the packet and the packet length, and hence the size of the packet can arrive from upper layer and can only be 339 bytes. Now this L2 CAP divides these large packets into segments and adds extra information to define the location of the segment into the original packet. And this L2 CAP segments the packet at the source and reassembles at the destination site. Okay, now here, what is the other duty of this L2 CAP? We have the quality of service as well as the group management. In this quality of service, all the stations to define the quality of service level. And the group management is this functionality of L2 CAP allows devices to create a type of logical address. Okay. And next, whenever we have 2 or 3 secondary devices can be part of a multi-CAP, also can receive the data from the client. Okay. Thank you. See you in the next session. All the best.